Hello students, this is the fifth lesson in Unit 2. We're going to be talking about triangle angle proofs. This is the first time in geometry we're going to be talking about proofs, the first of many. A proof is just a way to show a mathematical argument in a step-by-step form. You can see that there is a former problem that you did in a previous lesson here, and a strange new way of writing out that problem. Looks a little bit neater, a little bit cleaner. I'm going to show you all about it. Let's take a look at the learning target. In this case, the learning target is I can compose a logical argument. Compose a logical argument just means write a step-by-step argument here for solving a geometric problem, where we've been solving geometric problems basically all year, by writing a statements and reasons proof. I'm going to talk about what the statements are and what the reasons are in a moment, but right now let's think about this equation. You can see the equation from here to here is solved. And there's a number of different reasons why we went from this step to this step, from this step to this step. Take a few moments to try to figure out the reasons for each step. Why did we go from here to here? Why did we go from here to here? There are mathematical reasons for each step. So try to figure those out and come back to see if you got them right. All right, I made some marks on the equation here to show sort of what I did. From here, I multiplied 2 times 4x and 2 times 5. I used the distributive property, and that's why I wrote down in the reasons distributive property. From here to here, I used distributive property. Then 10 plus 20 gives us 30. That's combining like terms. That's why I wrote that here. Then from here, I subtracted 8x from both sides, which means I used inverse operations or opposite operations. And to be specific, I did subtraction. And then from here, I had to divide both sides by -5 to get -6 as my final answer. And in order to get from here to here, I used opposite operations. All I did was I provided a reason for each step of the solving process, or the solution process. What I just did was write out a proof. Now, to be specific, what is a proof? In this case, or in every case in math, a mathematical proof is a step-by-step argument, kind of like the argument that we made up here, all the way from the beginning to the end. So the mathematical argument that begins with the given facts, makes several true statements. In this case, the statements are all of the steps of the equation. The true statements about the problem that are justified by reasons. All of the reasons are shown up here. And it ends with the thing you're trying to prove or find. In this case, we were trying to find the value of x. In a geometry problem, sometimes we're trying to prove that two things are equal or prove a fact about a shape, but also sometimes we're trying to find the value of a variable. Here's one example of a problem that we've done in the past. It was a problem from, I believe, the problem set from lesson 3. Now, when you're looking at this when you're looking at this problem, what's sort of difficult to figure out when you're just looking at the work just like this? Pause the video and try to figure that out. It might surprise you to know that in this problem, the first step wasn't exterior angle theorem. It was actually the triangle sum theorem. Hopefully you've done this problem already from the problem set, so I didn't have to show that to you. The next step that they did after the triangle sum theorem, again, this was step number 1. Step number 2 was doing the exterior angle theorem. It wasn't really in order. And when you're doing a problem like this, a lot of algebra steps in a problem like this, it's not always easy to keep your steps in order. Sometimes you just have to write down the steps as you see them on the page. It's difficult to figure out where the person started out. You know that there are multiple steps, but you're not always sure where they started and where they ended and how they got to this angle. However, the method that I'm going to show you today is called writing a geometric or mathematical proof. A proof actually shows you step by step how the person did what they said they were going to do. In this proof, I'm looking at the first step, which says JEA is equal to 90, EAJ is equal to 48, and EMS is equal to 59. All of these angles were given to me at the beginning of the problem. We have this angle that's given to us here. It tells us right away in the problem. Angle 48 is given to us here, and angle 59, or angle EMS is equal to 59, I should say, is given to us here. All of those things were given to us. That's why I say given at the beginning. If you remember from the do now, the first part of the equation was just the equation that was on the page at the beginning before I did anything to it. So this is the equation as it was given to me. In other words, it's where you start from. Then we go through the first step, which is to find angle J. And if you wanted to know how we found angle J, all you have to do is look at the reason. We use the triangle sum theorem. And it should make sense to you that triangle JEA has this angle that we don't know and these two angles that we do know. So we could use the triangle sum theorem to find that out. I don't have to write out all of the algebra when I'm making a proof. All I have to do is say, I found the measure of angle J to be 42 degrees. And then for the third step, it says we did the exterior angle theorem. I outlined that in green here on the problem, but it's not necessarily very obvious which one I did first or second. But now that you see it as the third statement, you could say, oh, after I found this angle using the triangle sum theorem, then I found the measure of angle JSM using the exterior angle theorem, using this exterior angle out here and these two interior angles, right? Exterior equals interior plus interior. Here's the work, but it wasn't necessary to show the work for the proof. All you have to do is show your answer and your reason. This method, algebraic or geometric proof, is a way to show your argument based on some certain statements, the reasons why you say those statements, and the last step should always be the thing that you are trying to prove or the thing you are trying to find. Keep in mind, we were trying to find JSM, angle JSM, and we ended with that. So that's geometric proof in a nutshell. Instead of rewriting a problem that we've already done, let's take a look at a new problem and try to figure out how to write a proof for it. So in this problem, it says that the measure of angle W plus the measure of angle X plus the measure of angle Z is equal to 180. And that sort of looks like it's going to be the triangle sum theorem, right? Because angle W and angle X and angle Y, this is three angles and they add up to, this is Z rather, they equal up to 180. However, these three angles are X, Y, and Z. This is X, W, and Z. There's something going on here. So we have to figure out a way to try to make this equation based on things that we already know. Pause the video and try to figure out what we know about this triangle and what the first thing is we can write in for our statements. Alright, I started out with one fact that I know for a fact in this situation, which is angle X plus angle Y plus angle Z are equal to 180. That's based on something called the triangle sum theorem, a theorem that we learned about a couple of lessons ago. Since this equation is not the same as this equation, let's try to figure out the differences between the two equations. I can see that most of the things are the same. However, the X and the Z are the only common bonds here. This W and this Y are different. So I have to find out a way to take out this take out this Y and substitute a W in there. So let's take a look at W and Y, and let's look at the relationship between them. Here's W, and here's Y. So one piece of information that you should know about these two angles is that they share a vertex, and they're formed by two intersecting lines, and they are not adjacent to each other. So one piece of information that you should know about these two angles is that they are vertical angles. Let's go to that next. So the next statement that I can write is that the measure of angle W is equal to the measure of angle Y, because those two angles are vertical angles, and we know that vertical angles are congruent. Easy. Now let's take a look at the relationship between the equation that we wrote on the first statement and the second equation that we wrote. What I want is for the equation to say X, W, and Z equals 180. And I have a Y in here that I don't need. What I can do is take this, the fact that the measure of angle W is equal to the measure of angle Y, and use it to take W and substitute it in for Y. In other words, if I know these two things are equal, I can take out one of them and substitute in another. Here's what that looks like. Alright, here you should be able to see that we took that Y and took it out and we substitute it with W. So X plus W plus Z is equal to 180. We know that W plus X plus Z is equal to 180 is what we were supposed to prove, and we have gotten that equation. It's a little rearranged. So what we should do for our last step is sort of take this equation and use it as a model to rearrange this equation. All right, measure of angle W plus measure of angle X plus measure of angle Z is equal to 180. That's exactly what we had to prove, and we got there by using the commutative property, which states that I can take two angles that are being added together, or two anythings added together in an equation, and swap their order. Easy stuff. Keep in mind that the commutative property is something that you learned about in 8th grade math, and we went over it in algebra as well. If you don't remember stuff like that from algebra, don't worry, because we're going to be seeing a lot of that old stuff coming up soon. In the model problem number 2, it's a little bit different because it gives us some numerical information as well. let's take a look at how it would look if we labeled the diagram. Let's label the diagram first. All right, look at a lovely diagram here, all labeled up. We have right angle BEA, which is here. We have EBD and CBD are the same, so we put X's for them to represent the fact that they're both the same. EBA is equal to 52, which is here. And then angle D is up here, which we do not know. Now, we don't have a whole lot of information about particular things in this diagram, but we do have some useful information. We know that this angle is 52 and this angle is 90, so we're going to be able to find this angle, this missing angle down here, by a little thing I like to call the triangle sum theorem. But before I do anything, I have to write down all the things that were given to me. That's right, the first statement is going to be the givens. All right, all my givens are here. I have everything that was given to me in the original problem. Now I can move on to some stuff that I make up myself, which is 52 plus 90 plus whatever this is equal to 180. So I can find this out to be 38. Remember, I don't have to show the work necessarily, but I do have to write it down in my statements and reasons. So it might be a good idea for me to show it out just so that I know I'm writing the right number down. All right, if I was doing this algebraically, I would write out triangle sum theorem, angle plus angle plus angle equals 180, and then substitute and solve. I don't have to write that out if I'm asked to write a statements and reasons style proof. All I have to do is find the measure of the angle and say triangle sum theorem. Not bad. Now I could see that there's an easy way to find these two missing angles, which is by recognizing this straight line and the fact that that straight line is made up of 3 different angles. That's right, these 3 angles add together to equal 180 because of supplementary angles. So that's the next step I'm going to take. Okay, we used supplementary angles to find that x is equal to 64, and then we were able to identify not only is this angle 64, but this angle is also 64. So on the same line, I found out that EBD is 64 and CBD is also 64 based on that one concept of supplementary angles, that my reason is supplementary angles. Last but not least, let's look at the relationships here. I have this angle up here, angle D, which I don't know yet, but I have this triangle and an exterior angle for that triangle at 64. So I can take 38 degrees and this angle, add them together, that should be equal to 64. In other words, I'm going to be using the exterior angle theorem. Here's how it looks. Here's my exterior angle theorem setup, where I use the exterior angle of 64, the interior angle of 38, and this unknown interior angle. In the formula, I solved for the unknown interior angle, which is 26 degrees. This is just another way of writing out a question that you might have multiple different steps on, and it's a good way to write it out because it shows you all of the different steps in order. All right, that was the video on triangle angle proofs. Keep in mind that sometimes we'll be asking you to write proofs in this style, and sometimes we'll be asking you to write them out algebraically. Just make sure that you know what the question is asking. Good luck studying.